Hello, okay, sir, going to discuss this question. Right, look at this problem and try to solve the problem before looking at my solution. So 5 yellow ping pong ball number 1, 3, 5, 7 and 9, so which is all the odd number is in the box A, right? And 3 white ping pong balls number 2, 4, 6 is in the box B, right? Are mixed thoroughly in each box. So means that, alright, now we're going to know that for box A, we have 1, 3, 5, 7 and 9, right? 1, 3, 5, 7 and 9. Whereas for box B, right? Box B, we have 2, 4 and 6. Okay, we just assume the ball to be the number, right? To be the number, right? Okay, then later on we try to read back the question. So a ball is randomly selected from each box, right? Means that select a ball, only one ball from box A and one ball from box B, right? So if X denotes the sum of the number obtained from each ping pong ball selected. So X is denote the sum of the numbers, right, obtained from each ping pong ball selected. The meaning here is probably you from the box A you're getting a ball with number 3, and the box B you're getting a ball with number 2. So you add up the score, you add up the two scores. So the score can be 1 and just now if I take 3 from here and here 2, then the score will be 5, right? Then the score will be 5. So we have to construct a table of probability distribution of random variable x. For now, even though the question never tell you, you have to know that x is a discrete random variable, right? It's a discrete random variable. How you know? How you know this is a discrete random variable? Because you have the integer value, right? When you sum up the score here, you take 1 plus 2, you have 3. You take 3 plus 4, you have 7, right? It's a discrete random variable. It's countable value, okay? It's a countable value. So what should I do will be, I'm going to list out, okay, all, I'm going to draw out the sample space, okay? All the possible outcome is better. So you have 2, 4, 6, right? For box B, right? And for box A, we have 1, 3, 5, 7 and 9, right? So we can list out, okay? We can list out all this. So because this case they actually asking us to the x here, right? The x here is refer to the sum, right? The sum of the number obtained from each ping pong ball selected, right? So if you take 1 from here, from box A, and you take another ping pong ball from box B, right? For example, 2, right, from box B. So the total score will be 3, right? So we just total up the score. 3. 3 plus 2, we have 5, right? 5 plus 2, we have 7. Total up the score. So 7 plus 2, we have 9. 9 plus 2, we have 11, right? So we want to see how the score distributed. So 1 plus 4, we have 5, right? 3 plus 4, we have 7. 4 plus 5, we have 9. 4 plus 7, we have 11. And 4 plus 9, we have 13, right? Can you see that? So then we list out again before we construct the probability distribution table. So it's better for us to see the distribution. So 6 plus 1, we have 7, right? 6 plus 3, we have 9. 6 plus 5, we have 11. 6 plus 7, we have 13, right? So and 6 plus 9, the maximum value, the score that the maximum with the biggest number here plus with the biggest number here, right? So we have 15, right? 15. So so we construct the distribution table, right? I'm going to show you how to construct a distribution table. We're going to list out all the possible score here, right? X denote the sum. You have to understand the question. Denotes the sum of the numbers obtained from each ping pong ball. So you take from the box A and you take from the box B, so you add up the value on the ping pong ball, then you will get the score, right? So then you have x is a discrete random, right? Because what you can see there is a fixed value, right? So you know that all is an integer value and countable. So you know that you have 3. The smallest will be 3. This is your discrete random variable 3, and followed by 5, followed by 7, followed by 9, followed by 11. Okay, so 13 and 15, right? This is all the possible value, right? 3, 5, 7, 9, 11, 13, 15, right? So to get one of these, the probability will be probability of getting 1, right? 1 from box A and getting 2 from box B, right? So very simple, because this is just 1 out of the 3 number in box B, right? Box B. So each of the probability here of getting if you want to take a ping pong ball from box B, each of them you have 1 over 3, right? Probability of 1 over 3 is fair, right? So this one also 1, 2, 3, 4, 5. So this will be 1 over 5, right? Each of them will be 1 over 5. So means that each of these represent the probability of 1 over 5 times with 1 over 3, right? 1 over 5 times with 1 over 3, sorry, 1 over 5 times 1, we have 1 over 15. We have 1 over 15. Means if you see that 1, 2, 3, 1, 2, 3, 4, 5, 3 times 5, you have 15 elements here, right? 15 outcomes here. So, so it will be 1 over 15 for each, right? So 3 is 1 over 15. The probability of getting score x equals to 3, right? The score x equals to 3. You have only one possibility. It's 1 out of 15, right? 1 out of 15. 1 out of the 15 number here. Okay? So it's easy if you're able to construct this. Okay? So if you see 5 is only 2 of them, right? 2 of them. 2 out of how many number here? 15, right? So it's 2 out of 15. Then you have I think you already know how to write 7, 7, 7, right? So you have 3, 7. So 3, 7 out of 15. So it's 3 over 15. Slowly doing 9. How many? 9. 9 also have 3, right? 1, 2, 3. 3. 3 out of 15. 11. 11. You have 3 out of 15 also, right? 1, 2, 3. 3 out of 15. And 13. You have 2 out of 15. Followed by the last one, 15. The biggest score here will be 1 out of 15. 1 out of 15. So I already construct the probability distribution of random variable x. Then it's understood that this x, you should understood that x is a discrete random variable. Can you see that? They have a finite value, right? Countable. And you add up all the probability here. You have 1, right? If you add up, you see, if you add up this 1 plus 2, you have 3, right? 3. 3 plus 3, 6. 6 plus 3, 9. 9 plus 3, 12. 12 plus 2 plus 1, you have 15 over 15, which gives you 1. So it's confirmed that x is a discrete random variable. That's why the question asking you to construct a table of probability distribution of random variable x. You have construct by using this. Later on, hence show that x is a discrete random variable. Yes, you have to show it. You have to show, sorry, this is with x. So you have to show that the sum of the x. So if you're hardworking enough, you have to write everything here. 3, 5, 7, until the end, alright? Please be hardworking, writing everything. 15. So equals to 1 over 15 plus with 2 over 15 plus with 3 over 15. You have to write everything until the end, 1 over 15, which will definitely give you the value of 1 here, right? So you have already shown that So since the summation of the probability, right, or the probability here is equal to 1, therefore x is a discrete random variable, right? You have shown all the working, and now you know that this is definitely the method that the question 1, okay? The question 1 is to show that it's a discrete random variable. At first, you have to list out all the sample space, right? Then from the sample space, you determine the probability, right? So then you have to identify what is the discrete random variable here. The discrete random variable will be 3, 5, 7, 9, 11, 13, and 15. Alright, it's the sum of the score of the box A and box B, right? The ball from box A and box B. So later on, okay, let's look at part B. Alright, okay, I have rewrite the table in this form. So now the question is asking us to find the probability, right? Find the probability that x is between 5 and 15, right? 5 and 15. So probability of x is between 5 and 15. Right? X is a discrete random variable. It's a discrete random variable. So you can see that what is the value between 5 and 15, right? So between means you cannot include the 5, okay? You cannot include the 5, right? So means that it starts with 7, so means it include 7, right? Any value in between 5 and 15, 5, 9, 11, and 13, right? So probability of this one, 7, 9, 11, and 13, x, right? Between 5 and 15, so this is the value here. So it's just add up all the probability here, right? You just take 3 over 15. You can just simplify this. It's 1 over 105, 3 over 15 plus weight, 3 over 15 plus weight, 2 over 15, right? 3 plus 3 plus 8, 9, 9 plus 9 plus 2, 9 plus 2, you have 11 over 15. So this is the probability required by the question 4b, right? Not very difficult, this question. Okay, later on, the question requires you to find the expectation value of this variable here, right? Of this function, expectation of this function for this distribution, right? Okay, let's see how we're going to finding this. So as they require you to find e 2x minus 3 to the power of 2, right? So for this function, so at first you should expand this, okay? You should expand this. So you expand this, you have 2x minus 3 multiply with 2x minus 3 because power of 2, right? So as you know that after you expand, you have 4x to the power of 2 minus with 2, 2, 4, 4, 3, 12x plus with 9, right? So as you can apply the properties, right? You can apply the properties. So then we can rewrite this to be the expectation value of 4x squared, right? Minus with 12ex. Expectation of 9, you were getting 9, right? If you still remember the property, if you have ax, you will take out the aex, right? So if you have ax plus b, right? Ex plus b, where b and a and b is a constant, you can write as aex plus with expectation of a constant, you're getting b, right? Just like this, okay? Expectation of 9, you're getting 9, right? 12. Okay, expectation of negative 12x. So you take out the negative 12, you take out negative 12ex, right? This one also, you can just doing this 4ex squared, right? 4ex squared minus with 12ex plus with 9. This is the most important part here, right? It's the most important part here. Now very simple, you just have to find the value of ex squared and the value of ex by using the probability distribution table. Alright, okay, let's see how I'm doing this. Right, let's see how to calculate the value of ex. Ex very simple, right? Okay, you have learned before. So ex, you just take is the summation, sum of the multiplication of x with the probability, right? For all the random variable, you just sum up. So you just show you're working 3 over 1 over 15. Just take this multiply with this one, plus with 5 multiply with 2 over 15, plus with 7 multiply with 3 over 15, so on and so far. Later on 9, 11, 13 until the end, alright? Until the end, 15 multiplied with 1 over 15, right? Okay, I will give you the value. So the value we're giving 9, right? The value of 9. So same thing also, you need to find the value of ex squared, expectation of x squared. So it's the same, just you squaring the number here, right? 3 squared, 3 squared with 1 over 15, plus with 5 squared with 2 over 15, 5 squared with 2 over 15, 7 squared multiplied with 2 over 15 also, right? Sorry, it's 3 over 15, okay, 3 over 15, until the end, until 15 squared multiplied with 1 over 15, alright? So this is a basic knowledge. So you were getting the value of 275 over 3. Alright? 275 over 3. Okay? As simple as that. Okay, later on you're going to substitute this value into what required by the question. Right? So you know that therefore your expectation of 2x minus 3 squared for this function is the same as this one, right? After applied property, your ex squared is 275 over 3, 275 over 3 minus with 12ex, your 12ex, your ex is 9, plus with 9, alright? Plus with 9 using this, right? By applying the properties. Then your final answer here after you apply is 803 over 3, right? You can change it into a decimal form or you can change it into a proper fraction. Doesn't matter, I just tell you this is the way we solving the question B, right? Solving question B. So, C. So calculate this one, right? Expectation of this function. So now we have to calculate the variance for 5 minus 2x. Okay, let's see how to do this. Alright, for part D, they require to find the variance of 5 minus 2x. Definitely you have to know the properties, right? The properties of discrete random variable for variance and mean expected value. So variance 5. So you know that variance of a constant, you are getting 0, right? So if you have variance of ax, based on the property, you have a to the power of 2 for the variance of x. So same thing also, if you have variance of ax plus with b, you just follow through this, right? Variance of ax, you will have a to the power of 2, variance of x. And variance of b will be, is a constant, right? You're getting 0. So now for this case here, very simple. Variance, right? Variance of 5. Variance of 5. So according to this, you are getting 0, right? And for this variance of negative 2x, right? Variance of 5, you know is 0. Variance of negative 2x. So you're taking the negative 2, and you go and put the power of 2 here. So it becomes variance of x, which is 4 variance of x, right? 4 variance of x. Okay, later on we can apply, right, formula for variance, right? Formula for variance, so which is ex squared. Variance is, you know that the formula for variance will be ex to the power of 2 minus with the mean, right? The mean or the expected value of x squared, right? Which is you already found just now. Ex squared will be 275 over 3 minus with 9 to the power 2, right? 9 to the power 2. Then you can get your answer, and your answer will be 128 over 3, alright? 128 over with 3. So this is your answer for this question. So hope I already teach you how to solving this question. That's all for this video.